For the past 45 years, professional transmission rebuilders worldwide have trusted Freudenberg-NOK and its TransTec brand to supply the highest quality kits and components to the independent automotive aftermarket. And when they see that familiar black and gold bag, they know they are not only getting the highest quality, it's also the most complete kit on the market. To ensure we are incorporating the most complete and accurate content, TransTec kits undergo a rigorous development process led by our team of product technicians, along with both application and design engineers. Let us show you how that happens. It all starts in our state-of-the-art research and development lab in Milan, Ohio. Located near the Ohio Turnpike and quite literally in the middle of a cornfield, this Freudenberg-NOK location is the North American aftermarket headquarters. The facility boasts over 265,000 square feet of assembly and warehouse space, along with administrative offices, the R&D lab, a full-service maintenance department, and even a compact production cell where we manufacture small batches of Teflon sealing rings. When developing a new kit, the team first performs extensive research by combing through designs, reviewing online data, soliciting customer input, and sometimes even looking at message boards. This research takes place prior to beginning the process of disassembling the selected application. During the disassembly process, all sealing components are collected, reviewed, measured, and tagged. The team identifies specific challenges in removing the components and makes detailed notes of placement, directional fitment, and any other noteworthy observations. When available, manufacturers are identified as well. In many cases, what we find is that because Freudenberg is an OE manufacturer and is in partnership with most major automotive brands, numerous components that are removed from the unit already exist in our portfolio. The components that do not exist within our current offering are sent to our engineering department for further review and, when necessary, print design. Engineering associates begin their process by measuring the components and their mating hard parts. They record all pertinent information about the application and component functionality. Details such as rotational direction, heat and pressure requirements, and hard part material are essential to properly design each part. Components are designed using 3D modeling software. From there, prints are drawn to be sent to our pre-approved suppliers. As part of our overarching strategy and brand promise, suppliers are approved based on their ability to produce the highest quality components. In order to ensure quality, suppliers must meet strict criteria put in place by our product development team. Whenever possible, an OE manufacturer is selected. Upon receipt of pre-production samples and PPAP documentation, the engineering team in Milan validates that the components have been produced to the required specifications. Dimensional data is recorded and compared to the design print, and material properties are confirmed using the preferred method of infrared spectroscopy. The industry-recognized device used by Freudenberg-NOK is called the Fourier Transform Infrared, or the FTIR. After the validation process, engineers from the application and design teams install the samples into the test unit to ensure proper fit and function. These associates employ the same methods, techniques, and tools that are used by technicians globally. Upon validation of samples, production parts are ordered and test plans are created. Test plans provide a visual representation with dimensional data and material properties. When full production parts are received, they will undergo initial inspection by a member of the quality team. The quality technician uses the test plan to validate that the supplier has produced the part to print specifications. Subsequently, the next two receipts of the component are also verified to the test plan before being placed on a rotating schedule of incoming inspections. Depending on the type of component, different tools are used in conjunction with the test plan to perform the validation. For example, this valve body gasket is compared to the Mylar drawing to ensure it meets print specification. Gasket thickness is also confirmed by the use of a digital caliper. When components have passed quality inspection, they are then placed into inventory before being moved to the production area and later built into kits. Keeping in mind both the size of the components and the location within the transmission, detailed bills of material are created. Smaller components are grouped together in subkits based on size, type of part, or in some cases on subassembly as it relates to the specific area of the transmission. For example, you'll find a sealing ring kit in every application, and pump assembly components will be packaged together to make the rebuilder's job just a bit easier. Overhaul kits are built in a series of steps, beginning with the production of individual subkits. After subkits are assembled, they are added to the main kit along with all the individual seals, gaskets, and miscellaneous items required to complete a full transmission rebuild. During every production run, the first kit down the line is pulled for inspection. Each part is matched to the quality inspection board to ensure that all subkits and components listed on the bills of material are accounted for. Additional periodic inspections are performed during the production build to ensure quality is maintained throughout the process. These inspections are documented and the records are maintained for future reference in case a quality concern arises in the field. Finished kits are placed into inventory and are immediately available for shipment to our distribution partners. From there, they are shipped to transmission shops worldwide where they will be installed by skilled technicians.